Hey everybody, back here for the second half of part 5, or problem 5, part D, E, F, G, I believe, H, and maybe even I. Yeah, all the way through I, so let's get this thing started. So in the last part of this problem, we showed that z squared star is equal to z star squared. Okay, now what I do know is that based on this problem, z squared is negative 5 plus 12i. So the conjugate, which is what this symbol here obviously means that this would be equal to negative 5 minus 12i is equal to z star squared. This tells me that there are going to be two answers for this z star such that they are roots of this thing. So let me back up. So z squared star is equal to z star squared, which I'm going to write as negative 5 minus 12i, okay? So z squared we said was equal to negative 2 possible answers here. Negative 2 minus 3i squared will equal negative 5 minus 12i, or star, missed that, or 2 plus 3i squared star will equal negative 5 minus 12i. So if these two are interchangeable, as you can see, square and star are interchangeable, square, star, interchangeable, then these two are interchangeable. Therefore, 2 plus 3i star, ooh, that was a really good star, squared should equal negative 5 minus 12i, and so should, from this example, negative 2 plus 3i. Apple Pencil just died. So there you have it. Whoops. I already took the conjugate. Shouldn't have done that yet. So let me change this piece here. It should be a minus there. So the two square roots of negative 5 minus 12i will be negative 2 plus 3i, right? The conjugate of negative 2 minus 3i, and the conjugate of 2 plus 3i, which will be 2 minus 3i. There you have it. Pretty confusing for a 2-mark question. Let's see if you can work your way through that. Okay, part E. Part E is giving us a polynomial of degree 4, which means it has 4 roots. Although we see it only has, based on its graph, 2 real roots. Here at negative 4, 0, and 2, 0. That means there's 2 imaginary roots somewhere. So it says explain why of the 4 roots of the equation f of x equals 0, 2 are real and 2 are complex. Well, we could say since there's 2 real roots, okay, we see 2 real roots. 2 real roots at negative 4, 0, and 2, 0. Therefore, there's 2 imaginary roots. Write out that whole word when you do this on the exam. And they are complex conjugates. Awesome. Let's move on to part F and see what that's got in store. So it tells us that the curve passes through the point negative 1, negative 18. Well, we already know our 2 real roots, negative 4 and positive 2, I believe it was. So I can go x plus 4 and an x minus 2. And then all I have to do is solve for c and d. And I can do that by plugging in a negative 1, excuse me, for x and getting out a negative 18. So let's do that. Negative 18. If I plug a negative 1 in here, looks like I get 3. Negative 1 in here, I get negative 3. Negative 1 in here, I get 1 plus, minus c plus d. Let's do a little algebra here. That'd be negative 9 times 1 minus c plus d. Therefore, it looks like you get 2 equals 1 minus c plus d. So we could say that 1 equals negative c plus d. Another thing that I know from the graph, as you can see above, is that if I plug in a 0, I get a negative 32. So if I plug in a 0, I get a negative 32. Let's do that on a separate line here. Negative 32. If I plug in a 0, I get a 4. I get a negative 2. And it looks like I get d. Therefore, that should be a negative 32, not a negative 30, 32. Okay, so that's negative 32 equals negative 8 times d. So it looks like d equals 4. Therefore, if d equals 4, then 1 equals negative c plus 4. Therefore, c has to equal negative 3. Awesome. So we're going to find f of x in this form. So f of x will equal x minus a negative 4, x minus 2. Notice how I'm putting it in the form that they want. X squared minus or plus a negative 3x plus 4. And there is the equation for f of x. Let's look at part G. G says find the two complex roots of the equation f of x equals 0 in Cartesian form. All that that's asking us to do then is to find the zeros of that there. So x squared minus 3x plus 4 is equal to 0. I don't think we can factor that, so we use the quadratic formula. X equals negative b plus or minus square root. That was not my best. B squared minus 4ac I think comes out to be negative 7 all over 2a. So let's put that in a nice clean form. That would be 3/2 plus or minus I root 7 over 2. All right, there you have your two complex roots. So we know that we had a root at negative 4, a root at x equals 2, and then these two other roots. And they come in complex conjugate pairs. Awesome. I don't know that I put the next part of this problem on this page, so I'm going to come back and finish this with another video. See you next time.